Okay, good morning class. So today we're looking at Euclidean Geometry. At this point we're looking at examples for exercise 9.3. So as I have indicated before, or earlier on now, that exercise 9.3 is not a proof theorem. It's actually derived from theorem 2. And theorem 2 says angle at center is twice angle at circumference. Not so. So if we look at this here, what's the size of this angle on that line? 180 degrees. And what's half of 180 degrees? 90 degrees. Can you see that, people? So in other words, if this is your diameter, then your diameter will subtend 90 degrees. Yeah, it's page 2. 86. Thank you. No? The examples on page, the exercise on page 286, and the examples on page 285. Okay. So people, if you need to use this theorem, we now don't say angle at center is twice angle at circumference. What we basically just say, if you have a circle and this is the diameter of your circle, if that's the diameter of the circle, and of course this must touch the circle, right? Then what can we conclude? Then angle A is equal to 90 degrees, and the reason here is angle in semicircle. Okay, you can make a note thing. And if you have a circle and you have 90 degrees in the circle, this is now 90, and that is ABC. Okay, if that's the case, then you can conclude that AB is a diameter. Why? It's either converse of angles in the same segment or 90 degrees subtended by chord. Okay. You'll see the application of them in the upcoming exercise. The full lesson can be found in the description box below. Alright, so let's see what they say here. They basically told us that, let's take this off here. In theorem 3a, the angle subtended by a diameter, now you see this is diameter here, not so. The angle subtended by the diameter at the circumference of the circle is a right angle. Okay. So sometimes in the exam, we can tell you, okay, fill in the missing words. We say the angle subtended by, we leave this blank. Diameter at the circumference of the circle is a, we leave that blank. Okay, so it's important also to write down the theorem in words. Okay? We are told that AB is the diameter of circle, then angle C is going to be 90 degrees. Reason for this? Angle in semicircle, which I just said now. No? Then the converse, what's the converse? The reverse. Not so. The converse to 3 is 3b, of course. A chord subtends an angle of 90 degrees at the circumference of the circle. Then the chord is a diameter. It has to be a diameter. Not so. If you've got 90 degrees subtended by a chord, this has to be a diameter. So your diameter subtends 90 degrees, and 90 degrees is subtended by a diameter. Okay? And the reason here, chord subtends 90 degrees. So 90 degrees subtended by chord. Okay? As I said, the theorem is not required for proving. Okay? So at this point, we only taught you 2 theorems that needs to be required for proving. Not so? Yes, sir. One of it is coming in your cycle test. Okay? This work is not in your cycle test, it's in the next cycle test. Okay? in your next exam, your mid exam. People given O, it's a bit bigger, given that O, XOZ is the diameter. Now if XOZ is the diameter, what do we know? Then angle Y is 90 degrees. Why? Angle in semicircle. Remember, don't get confused. If the diagram has that as 90 degrees, I'm sorry, as your diameter, then that is 90 degrees. Can you see that, people? If the diagram has that to be 90 degrees, and then AB is a diameter. Okay. So coming back to this question here. So if they tell us that XOZ is a diameter, then what do we know? Angle Y is 90 degrees. Why? Angle in semicircle, as well as W1 and 2. The sum of W1 and 2 is also 90 degrees. Angle in semicircle. Okay? W and Y are two further points on the circumference of the circle. W, X, W, Z, Z, Y, or X, Y, W, O are drawn. O2 is 68. So angle O2 is 68 degrees. And X2 is 42. The first question says, calculate the magnitude. The magnitude is the size. Calculate the magnitude of X1. Here's X1. How are you going to calculate X1? Sorry? Anybody? Z2, yes. And then, can I use alternate angles then? Why not? Not parallel. The lines have to be parallel. Anyone else? Angles on a straight line, and then you got O1. Yes? W145. Why? So this is 90. Did I tell you those two angles are equal? No? You can't say 45? You guys forget very quick here. Look here. Angle at center. Angle at center is twice angle at circumference. Don't you see it? How can you not see it? Were you doing the homework all the time? Remember I drew this on the board. And I said that angle at center is twice angle at circumference. So this is x and that will be 2x. If the same arc subtends this angle here, then this is 2x and this is x. If that same angle, the same arc subtends an angle at center and an angle at circumference, that is 2x and this is. So I'm using that one in green here. Can you see? Angle at center, twice angle at circumference. You will understand. So x1, angle x1 is going to be half of 68, which is 34. Why? Angle at center is equal to 2 times angle at circumference. Okay, 34 degrees here. You all okay with that? Let's look at B. B the one Z1. B is Z1. O1. So angles on a straight line, yes. And then angle at center is twice angle at circumference. Absolutely. You all agree with that? And there's another way. What do you know? We know that this is 90 degrees. So what is this? Sum in triangles. You guys see that? We're moving too fast. So XWZ is equal to 90 degrees. Y, angle in semicircle. Remember that is your diameter here, not the angle in semicircle. Now, Z1 plus 90 plus 34 equals 180. Y, sum of triangles, or sum in triangles. And that is triangle WXZ. Do I need to say this? So angle Z1 is equal to 180 minus 90 minus 34, 56. Okay. Any confusion here? No? And then C, Z2. What? Sum of triangles. What do I need? I need Y. But Y is? Angle Y is 90. So it's capital. No? So let's talk about vertex Y. It's equal to 90 degrees. Y, angle in semicircle. And then sum in triangles. No? So Z2 plus 90 plus 42 degrees equals 180. Why? Sum of triangles, and it's triangle XYZ. So angle Z2 is equal to 180 minus 90, which is 90 minus 42 is 40. Yes, Michael. Yes?
How come you wouldn't say that Z would also be equal to 34 degrees?
Sorry?
How come you couldn't say that Z2 is 34 degrees?
So the question is, why couldn't you say Z4 is 34? Because it's coming from, you're talking about this 34. But you was going with the fact that it's alternate. Not so?
No, sir.
Why would you say this is 34?
It's radius.
Sorry?
The radius.
Radius. There's a radius. There's a radius, there's a radius. So in this triangle, that angle is 34. Why? Because it's angles opposite equal sides. This angle is going to be 56. Angles opposite equal sides. I don't know how you're connecting Z4 or Z2 to it. Because here's no, that is a radii there. But this isn't the radii here. You understand? Anything else? I think for this sum, there's only one example, right? So with that, you should be able to do exercise 9.3 on page 286. You guys can start with it now, so that we can do part of it in this lesson. So, okay. So exercise 9.4, the first half. Yes. Sorry? Why am I using angle in semicircle? Remember? So this the question is how is the angle in semicircle working? So I explained to you earlier on. If this is a circle and this is your angle here. Say this angle was 170 degrees and this is the center of the circle. Then what's the size of this angle here? Sorry? Half of this, which is what? 85. Can you see that? So if this angle was 160, then what's the size of that angle? 80. Can you see that? Now, if we make this angle 180 degrees, then what's the size of this angle? 90. Not so? Why? Because it's angle at center is twice angle at circumference. Now, if we use a diameter, we don't say angle at center is twice angle at center. We make it shorter. And what do we call it? Angle in a semicircle. What's a semicircle? Half a circle. Can you see here? There's half of your circle. It's angle in a semicircle. Yeah. So if you draw another line here, let's draw this angle here. That would also be 90. This here would also be 90. As long as it's supported or subtended by the diameter, it will always give an angle at the circumference of 90 degrees. You understand? Anything else? How many sums are there?